Hello and welcome to double angle formulas. This is the last building block that we need before we're ready to put everything together of what you've learned in algebra and trigonometry for the final unit in this part of trig, which is solving trig equations. So let's see what we have. With double angles, these are just the formulas. Double angle meaning instead of a sine of a theta, it's a sine of a 2 theta. So 2 is doubling it. And these all come from the sum formulas. In fact, I find it easiest in the long run, if you have to memorize all of these, is to start with memorizing these two formulas. The sine of 2 theta and the cosine of 2 theta. They come from the sum angles because instead of there being an alpha and a beta, they're both the same angle, theta plus theta. And you can see the proofs here. You can go through them yourselves. I actually use these two formulas that I've boxed here to help me remember the sum formulas, because the sine of 2 theta equals 2 sine cosine is very simple, and it helps you remember that those are the ones that go sine cosine. And the cos of 2 theta is cosine squared theta minus sine squared theta, which is different from the Pythagorean identity, which is a sum of cosine squared and sine squared. So this tells you that the cosine of the sum is cos minus sine. So the formulas all fit together, and once you know these three major ones, it will help you remember the other ones. But these two are the ones that you're most likely to have to remember when you get to calculus. Okay, let's use them. Okay, so the first kind of problem that you'll have is one that starts with a triangle problem again. How do you recognize it's a triangle problem? It's if you're given a trig value and a quadrant. And remember, a trig value is always two sides, a ratio of two sides of a right triangle. And if it's cosine, it's adjacent over hypotenuse. So we have the -5 and the 13. And of course, we know this triangle without even doing Pythagorean theorem. We know it's a 5, 12, 13 triangle. It's well worth your while to memorize some of the most basic ones, especially 3, 4, 5, and 5, 12, 13. Come up very often. So just to get ready for everything, since we know we're going to have to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta, we'll just find them all right now. Sine is opposite over hypotenuse, so that would be 12 over 13. And tangent is opposite over adjacent, which would be -12 over 5. Now I've just written the template here to make it easier. Once again, it's very much easier if you have these formulas in your head. Comes very easily to you that way, but remember, we're not finding the angles, but what we are doing is knowing that sine of 2 theta is 2 sine theta cosine theta. So we'll fill in the parts that we're given from the above triangle. So sine of 2 theta is 2 times 12 thirteenths times -5 thirteenths. And I assume you can do these. You have your calculators, you can do them with your math that you know in your head. I'm just going to give the final answers for these. There are more steps if you look up the solutions. There are more steps given. But remember, the 2 is times the numerators. So 2 times 12 times -5 is -120. Then the cosine 2 theta, you have your option of using whichever formula you want, all cosines or all sines. I find it easiest to just use the cosine squared minus sine squared, because then the denominators are already the same and you're good to go. Now just remember that anytime you square anything, whether it's positive or negative, it's going to be positive because a negative times a negative is a positive. So be careful. Watch your parentheses if you're using your calculators. And this turns out to be negative 119 over 169. You can check your math. Make sure you're doing all these by yourself so that you check that you're doing the math correctly. And then the tangent of 2 theta is 2 times negative 12 over 5. And 1 minus negative 12 fifths, the quantity squared, which of course would be negative 24 over 5 over 1 minus, or 144. I'm writing this out so you can be sure to be careful. The negative 12 fifths itself squared is positive, but then there's a subtraction outside. So it's still going to be 1 minus that fraction. And if you can do that on your calculator, however you do it, to get 120 over 119, these all must be exact fractions. So be sure you know how to change decimals back to fractions in your calculator. And now we have our same type of problem we had with the sum and difference angles. We are going to have a formula, and it's guess what formula it is. And once you have that, then work backwards and simplify. So as soon as you see 1 minus 2 sine squared of something, then you know this is the formula that we're using. So we're going to write it as cosine of 2 theta. Now, what is theta? Well, theta is whatever is inside the sine squared. So it's 2 times pi over 12. And of course you have to simplify that. And once again, the same rule. 2 times pi over 12 is cosine of pi over 6. And the same rule holds true for this. If it's a familiar angle, you have to do it. So cosine of pi over 6 is cosine of 30. I always remember it. When I remember sine of 30 is a half. So the cosine of 30 must be the other one, which is square root of 3 over 2. There only are 2 answers when you're talking about cosines and sines of 30s and 60s. It's either a half or square root of 3 over 2. Okie dokie, so that's that one. And here we have verifying an identity again, and these were getting cumulative, so now you could very often have a double angle inside of an identity. So we have something very simple. On the left we have sine of 2 theta, which we know is going to turn out to be 2 sine theta cosine theta. That's what we're working towards. So on the right we have, you could do this a couple of ways, but I'm hoping that you see right away there's a 1 and there's a squared. Think back to those Pythagorean identities that we use so frequently, and remember that 1 plus the cosine squared of x equals cosecant squared of x. Anytime you can get rid of 2 terms and make it 1 term, that's the easiest way to do something. So first step, we're going to make this 2 cotangent theta over cosecant theta. Now we're going to simplify a complex fraction. So we're going to have 2 cosine theta over sine theta in the top. In the bottom we'll have 1 over sine squared theta. And so now we're going to have 2 cosine theta. We'll take the numerator fraction times the reciprocal of the denominator fraction. And once again, let me change colors here. We're going to take 1 sign out of the bottom and 1 of the signs out of the top, and end up with 2 cosine theta sine theta which we know is the same as 2 sine, I'll even write it out this time, 2 sine theta cosine theta, which is sine of 2 theta. And there we go. Now there is more in your study guide. If you look at the notes, a lot of times when you get to calculus next year, you'll probably get formula sheets that have what we call the power reducing formulas, and you may also have half angle formulas. They all are related. You can see that relationship between the two, how one comes from the other, so that you know that they come from this unit. But we won't be requiring you to be using those this year. Okay, have a good time.